Why is exploratory data analysis, or EDA as it's commonly known, such a critical step in the world of data science? Well, dear listeners, that's exactly what we'll unravel in this module. Imagine you're an archaeologist. The raw data is the unexplored land, and your tools are the EDA techniques. Just as an archaeologist would excavate and examine artifacts to understand the history and culture of a civilization, a data scientist uses EDA to understand the story hiding in the data. Firstly, we'll delve into data visualization, a key component of EDA. Think of it as the initial excavation. Data visualization involves creating interactive graphs, charts, and plots to visually explore the data. Libraries such as Matplotlib, Seaborn, and Plotly are excellent tools for this job. They allow us to plot complex data and glean potential patterns, trends, and outliers. Remember, a picture speaks 1,000 data points. Next, we move on to statistical analysis, akin to the careful study of an archaeologist's findings. This involves understanding the distribution of data and the relationships within it. Distribution analysis can reveal how data points are spread out and can help identify skewness, kurtosis, or even if the data follows a normal distribution. Correlation analysis, on the other hand, helps to understand the relationship between different variables. It can show if an increase in one variable corresponds with an increase or decrease in another. The final step in EDA is dimensionality reduction. Imagine you've unearthed hundreds of artifacts. You need to find a way to categorize and simplify your findings for better understanding. Similarly, dimensionality reduction techniques help to simplify complex datasets. They reduce the number of random variables under consideration by obtaining a set of principal variables. This can make modeling the data more manageable and more meaningful. To summarize, in this module, we've explored the 3 crucial steps in exploratory data analysis. We began with data visualization, using tools like Matplotlib, Seaborn, and Plotly to create visual representations of our data. We then performed statistical analysis, understanding the distribution and relationships within our data. Finally, we use dimensionality reduction techniques to simplify our complex datasets. Remember, the goal of EDA is not just to simplify data analysis, but to bring out the features of the dataset that further the interests of our study. It's about shedding light on the unknown, making the complex clear, and telling the story that the data holds. So, until our next module, keep exploring, keep discovering, and keep making sense of the world through data.